Okay, elementary matrices are the matrices you get for any n by doing a single row operation to the identity matrix I sub n. I sub n being the square matrix, n by n, with ones and diagonals, 0 everywhere else, and we know that. The inverse is the undo operation applied to the identity. Well, what are your row operations? Well, let's just do an example. Okay, multiply second row by 3. Okay? So your identity, that depends on what your n is. I'm just going to use n equals 3 because I want to write more than 4 notes. Yeah. More than 2 rows and columns. But I don't want to write too many. Okay? So 3 is good. So this gives you okay? The undo, you divide by 3. And implicitly you divide the same row by 3. Now if you multiply these matrices, 1, 0, 0 row times the 1, 0, 0 column gives you 1. 1, 0, 0 multiplied by either of the other columns gives you 0, because zeros are going to match up with the numbers that aren't 0. 0, 3, 0 multiplied by the first row, well, zeros match up with zeros, it's going to give you 0. Multiplied by the second row, the 3 is going to match up with the 1 through to give you 1. And third row times the second row times the third columns are going to match up 0, it's going to give you 0. So right now you got 1 from this, and then 1 from this, so you got the 1 here and the 1 here, zeros everywhere else. And the same thing, third row, 0, 0, 1 times the 0, 0, 1 column gives you 1, and gives you 0 elsewhere. So it's easy to verify this. Very, very straightforward. And if you didn't understand that, just do it yourself. Okay? So this is the inverse of this. Okay? If you switch row 1 with row 3, again, for n equals 3, you have this matrix, and it gives you this. Okay? Now, how do you undo that? You do it by the same operation. If you take this matrix and switch row 1 and row 3, you're back to the identity. That's clearly the inverse. And if you multiply it out, you find that it is the inverse. Okay? In other words, multiply this matrix by itself. Okay? 0, 0, 1 times column 0, 0, 1 gives you 1. And times either, first row times either other column matches up zeros gives you 0. And the second row by itself clearly gives you 1. Third row by itself clearly, third row times third column. Okay, I said second row by itself. Second row times second column. Okay, so it's very easy to verify that that's its own inverse. Okay? So the matrix is self-inverse. Let's add 4 times row 1 to row 2. Okay? Then get this, right? So that's a third type of elementary matrix. Okay? I'll undo by adding -4 times the first row to the second. Well, and doing this to the identity to get the elementary matrix. Okay? And you can verify that this also takes you back to the identity if you multiply this by this. Okay? First row times first column gives you 1, and times second or third column is going to give you 0. Third row times third column, same thing. Second row times second column, so it gives you 1. Okay? And otherwise, it gives you 0. You got to verify that because this row times the first column is going to give you -4 plus 4. And that's the key. Okay. Everything else is real obvious. Okay? Now, the determinant. What's the determinant of this matrix? Well, for this matrix, the determinant is 3. For this matrix, the determinant is 1/3. If you multiply the two matrices, the product of the determinants is 1, which it has to be because the two matrices, when you multiply them, give you the identity. And when you multiply two matrices, you multiply their determinants to get the determinant of the new one. Did that come up in your homework? Well, now you know it. Okay. Now, the determinant of AB is a determinant of A times the determinant of B. Okay? Pretty easy to prove if you got the summation notation, but I'll see how you're doing with that before I assign you anything that uses more of it. Okay? Make sure you're doing it right. Okay. Now, if you switch row 1 with row 3, well, what's the determinant of this matrix? Well, you're going to have 0 times determinant of this one, plus 0 times the determinant of the matrix you get here, or minus 0 times the determinant of this matrix, plus 1 times the determinant of the matrix you've got here. Well, determinant of this matrix is 0 minus 1. Okay? So determinant is minus 1. Okay? What's the determinant of this matrix? Look at it and see if you can tell me quickly. I don't think you get 4. The only minor here that is multiplied by anything but 0, if you go across the first row, is this one, and it's 1, right? The 4 only occurs in the minors that you get on the 0 and the 0. So the determinant is always 1. Okay? So switching a row, adding a multiple of a row to another row doesn't do anything to the determinant. Okay? Now there's a step in doing that, but that's true of any matrix. You'll see in a minute. Okay? So the only things that affect the determinant, or the only elementary matrices that have a determinant that's not 1, are this one, where the determinant is whatever number you're multiplying whatever row by it, it doesn't matter which row. Or if you switch rows, which changes the sign of your determinant. Okay? So that's very easy to verify. You just do a few examples. And that's, everything I've done here is real easy to understand. Okay? Now it gets just a little harder, but it's not difficult. To at least accept. Once I very much understand why. Okay? So let's say we have a matrix. This matrix. Okay? Now, if I multiply this matrix by this matrix, okay? Well, do that. Should be able to do it very quickly.